So yeah, last week we looked at subtractive synthesis with using more complex waves, and the subtractive part is where the filter is used. And this week we're looking at additive and FM synthesis, which is basically taking a really simple waveform and then adding frequencies to it. And in fact, for the first probably half of this lesson, we're not even going to use a filter at all. So that's kind of the main difference here. So I've just made like a basic drum groove here so that we can get started. And the first thing we'll start with is looking at a bass. And this bass is going to be, I guess, more typically a bass that you'd use for techno or like progressive. So for this one, we're going to use operator. And operator is really, really good for additive and FM synthesis for two reasons. One, because we have 4 oscillators that we can use here. And 2, because if we click over to this oscillator page, we can actually add harmonics. So let's add in a note here. I'll just do one big note. Got the filter cutting that out. Cool. So I'm going to pull up a EQ, and we're going to kind of use this as a frequency analyzer. This is going to help us see what's going on. So at the moment we can see with a sine wave, all we get is one pure frequency here. And in fact, we actually probably for this one want to go 1 octave lower. So what we can see here is we've got a really nice clean sine wave at the sub. But even with the sub, we can only just barely hear it. It's going to be more of a feeling sensation. So if we want to create a sort of low sine wave like sub, we still want some extra harmonics so that it fills up a bit of the mid-range, because something like a phone or even laptop speakers, or even like, you know, if we had these speakers without the sub, you wouldn't be able to hear this at all. So you want to kind of get the illusion that it's a sine wave sub, but you still want to be able to hear it all on all systems. So we do need to somehow add some harmonics. So first of all, let's see why we don't just use a saw wave. So if we grab our saw wave here, and you might say, well, this has heaps of harmonics and we can just use subtractive synthesis, pull the filter way down like this, and oh, that's sweet. You know, we've kind of got that low bass sound. But let's have a look what happens to the pitch if we do that. So if I grab a tuner here and put that there, we can see that when the filter's steady, it stays on D. But because the filter is actually so close to the fundamental frequency, if I move this filter around, you can see it actually changes the pitch of the note a bit. So it means that if we have some sort of like filter envelope or some sort of movement, we're actually, our bass note is not just staying on the same note, which means that if we have a sub that's not consistent on the same note, then everything else we're putting on top of it's going to sound sort of out of key with the sub. So it's really important that we want to maintain the tuning of our bass to be consistent. Obviously that doesn't happen if it's up here, because it's not as close to the fundamental frequency. But if what we're going for is like a really low bass like this, you can see the pitch shift is actually quite significant. So that kind of begs the question, how can we introduce some of these harmonics without distorting the pitch like this? So basically we know that the filter, if it's too close to the fundamental frequency, is going to be moving the pitch around. So let's get rid of the filter altogether and look at some other way of introducing those harmonics. So I'm going to change this one to a sine wave, and I'm going to engage this second oscillator here, and we'll make this a sine wave too.
So that doesn't happen in serum?
It does happen in serum, yeah. That's why, you know how I separated the sawtooth into having the sine wave separate? That sine wave doesn't go through the filter, so then we're only filtering the higher harmonics. And that way we...
Any synth.
Yeah. If the filter's moving, yeah. So if you're doing any sort of wubs or plucks and the filter's super close to the fundamental, then you'll get a bit of pitch shift.
So where does that sort of stop?
Probably above the second harmonic. Like third and up, it starts to become less obvious. And I also find that, say you've got a sound that is a higher octave, it's not as, I don't think it's as pronounced, or maybe it's just, maybe it is, but it doesn't sound as off as having the whole sub that's like changing pitch. And you know, a lot of our sort of bass rips and those sorts of things, we actually cut out the first two harmonics anyway. You know, if you've got a high pass on it, then those lower harmonics are not really being played. So it's mainly in the sub that we're really concerned about this. So we'll start here with the sine wave. And if we were to do additive synthesis, we could actually just go here. So we've got envelope, we can go oscillator, and we can just draw in some of those extra harmonics. Oh, I'm drawing them on the wrong one, silly me. So you can kind of draw in your tone like that if you want. But of course, then we can't automate how many of those are coming in and out. If you wanted to have, you know, we're probably not going to use any of this stuff up here. So we can just change this to 16 and it makes it a lot easier to focus in on these lower harmonics. And we can see that as I introduce these, they're just adding extra sine waves. So that's why it's called additive synthesis. And we can see there, we can get quite like a nice low sounding bass tone, and you could sculpt it just how you want. But there's another way that we can introduce those frequencies. And in operator, by default, if down here, we're using the first configuration where each oscillator runs into each other like this. When I add another oscillator, I'm not adding that oscillator next to it. I'm actually frequency modulating the first oscillator. So if I use this setting at the end, where you see they're all next to each other, and I introduce this, it just adds more to that. And if I put this an octave up, I'm just adding that sine wave there. But what we're going to be using today is this first setting, which is not adding, it's actually frequency modulation. So you probably ask, what is frequency modulation? Well, we know that modulation is when we move something. So frequency modulation is when we move the frequency. So I'm going to start by looking at this, not with one of these other high frequency or audible frequency oscillators, but I'm going to use a low frequency oscillator, also known as an LFO. So I'm going to select a sine wave here, and I'm going to apply this LFO just to the frequency of my first oscillator. And that sounds like this. So we're saying we're just modulating the frequency. We're moving the frequency around. But what happens if we start doing that at higher and higher rates? So if we go to low, we can see that gets to this point where it's moving so fast that instead of hearing and seeing the sine wave just move around, we're actually kind of hearing this as multiple different harmonics. And if I keep going higher, remember, all that's happening is that sine wave's moving around. But how we're starting to interpret this is that the sub actually seems like it's staying still, and we're just getting these extra frequencies on top. But some pretty special things can happen if the rate that we're moving that is actually at the same frequency that the note is playing at. So we're playing a D here, which is about 38 hertz. So what happens if we are moving that frequency around at 38 times a second, or 38 hertz? Then we start to get these sorts of tones. And we can see that as we increase this frequency modulation, there's a point here where the sub starts to drop away. And then it comes back, and then it pretty much disappears completely. So if we're designing this as a sub, we probably want to think about that because we don't want to lose too much of that sub energy. So we're going to choose somewhere around here where the sub's still nice and strong, but we've got these higher frequencies that we like. So we could go down here if we want it really mellow, or if we go up here, we get a bit more of that and we get our sub back. I find that because this is kind of a bit of a sensitive dance here, what we do is we get the first one to the point where we get a couple of these, and then we can engage the next oscillator. And then you can see again, we get to add some more frequencies without the sub dropping away.
So when you add an oscillator,
yeah,
it's adding the same frequency.
it is modulating,
Modulating
at the same frequency.
Right.
But
And because it's adding on, you're getting harmonics.
yeah. So that this,
Oh, sorry,
because it's
summing.
because it's moving it so quickly, but it's because it's moving it at the exact same frequency that one oscillator is oscillating.
Yeah.
It's a very harmonious sort of frequency modulation. We can hear that if we just change the fine tune a bit, it starts to become a lot more unsettled, and we kind of get like a wobble sound. We get all sorts of like these sorts of more crazy sort of wubby sounds. So what's happening is this one is modulating this one, which is modulating this one. That's what frequency modulation is, but knowing what frequency modulation is doesn't really help you at all to predict or know what it's going to sound like when it happens. And that's kind of where frequency modulation is really exciting, because you often kind of stumble across tones. And it's also something that you kind of do by feel. So now that we know that operator works as an FM synth, really what you want to do is just set these to sine waves, like so, and then just play around with these levels and just try and find whatever sort of balance you want to get the tone you want. But I recommend just having your EQ open to make sure that that sub doesn't drop away too much, like I showed before. So now what we can do is, say we wanted to get like a wubbing sort of sound. We could make these a bit shorter, say a quarter note each. And remember, we got to add some release, so we get rid of that click. And what is so cool about Operator is that each one of these oscillators has this envelope. So this envelope, the very top point where this point is here, is going to be wherever we set this knob. And as we draw in this envelope, this is the envelope that the knob is going to follow. So if I pull this back a bit, maybe we could get like, see, now we've got this deep wubbing sound, but our pitch is pretty much completely steady. There's a slight little variation, but it's nothing like it was when we were using the filter on the sawtooth.
Even when you change the fine tune, that stays.
Nah, then it's all over the place. So for sub, I would just keep it either on the same, or you could actually change the course to be an octave up or an octave down. So an octave down on the second would sound like this. An octave up. Oh, this is 4 octaves up. But you can hear that there's all sorts of really nice deep tones in there.
And so how long is that note that you
Yeah, so this note is, it's basically playing for a quarter note, but I've made it a 16th less and then just added that release so that the release is what's completing, is what's finishing this gap. Just so that the notes aren't overlapping.
Yeah.
And now, of course, because this is hitting on top of our kick, we'll just put a compressor on there. Sidechain that from the kick. So that's 500, so I think we'll play with this attack a bit.
What's 500?
500 is this full length here.
Oh, yeah.
But usually how I like to make these subs is I'll keep this envelope like that, and I'll just make one long note. So I'll just consolidate that whole thing, make one really long note. And then if we want to add this variation, we kind of want to automate this knob and this knob. But if we go show automation here and try and draw this in, basically the variation we want to make is like this much, and it's going to be so tedious if we try and draw that in. So we're going to go Control G and make a macro for that. And we're just going to set the minimum to say -18 and the maximum to -22. And now when we automate this, now we have this entire range to just make those tiny variations, and it just means that it's way less tedious. So if you ever have a knob on a synth that is super duper sensitive, and when it comes to FM, the knobs do get super sensitive, you can always make a macro and then make the mapping so it's a really short range, and then you now have the entire lane to just control that small range. So then maybe I would do something like this and duplicate that out. And we can, like, I don't know, put those ones a bit higher. Whoop. Sounds a bit funny. Maybe I'll move, maybe more like this is going to sound better. Last week, did we look at splitting the frequencies with side chaining?
Yeah, can we do that again?
Yeah. So what I'm noticing here is, you know, this, because the bass is always playing on top of the kick, when we're doing the side chaining, that movement, that boo 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 boo, is coming from the side chain. But if we want to get the sub clean enough, we want a longer release so that the bass is well out of the way of the kick. But it means that we kind of lose that effect that the bass is hitting on top of the kick, because it's now like has to move way out of the way of the kick. So what we could do is group this and open up our chains here. We'll call this lows. And we'll grab multiband dynamics. And multiband dynamics is a multiband compressor, but we're literally just using it for this region here at the moment. So I'm gonna map the high frequencies so that we can change the high crossover and the lows. And then I'm just gonna duplicate this 3 times. And the reason I've added this big complicated thing here is because it has the option to solo these bands. So lows, I'm going to solo the lows, mids, I'm going to solo the mids, and highs, I'm going to solo the highs. So now what I can do is on my mids, I can have a lot less compression. And on the highs, which I don't think there really are any in this, but I could have an even shorter release. So now we get this kind of illusion where we hear the click of the kick, and then we hear some high frequencies, which 2.5K is way too high. So I'm going to pull that down to maybe 800. So we hear the click of the kick, we hear a bit of the high frequencies of the bass, and then we hear then as the kick goes down a bit, we hear the mids of the bass. And then once the kick finishes, we hear the lows of the bass. But because that's all happening so quick, your brain just thinks the bass is playing over the kick. But what we're actually doing is we're ducking different parts of the bass out of different parts of the kick, and that way we can kind of create this illusion that the bass is playing on top of the kick. The other thing we can do, now that we've had this side chain split like this, is we can grab a saturator and we can go a lot harder on the mids with saturation, because usually we would be a little bit concerned about saturating our bass quite a lot because the subs would get distorted. But if we have it split like this, then the subs aren't being distorted at all, but we can distort a lot of the mids. Could even go up to 10, take that away there.
Is the clicking a problem?
I think is that coming from,
The compressor?
yeah. So that's probably the attack. See, what I actually end up doing here most of the time is I don't even use a compressor. I literally use a utility. And I'll just like just draw in the shape of my side chain, because that's just volume automation here.
Yeah. And you can actually see it.
Yeah, and then you can see exactly how they're all moving relative to each other. But
Which is similar to, I guess, LFO tool or shaper.
yeah, exactly. But as a rack, I would just make this and then press on this little floppy disk and save it, and then you never have to worry about like making this again. You can just, and you know, maybe I'll just add this to the email. Yeah, it is recording. But yeah, I would just add that to the email as well, this little rack for people that have Ableton 12. Probably a bit loud.
So is this something that can only be made in Ableton 12?
No, none of this is, all of this could be made in Ableton 10 or even 9 probably. Cool, so let's go ahead and kind of use that similar technique.
This might be a stupid question, but utility, when you draw it in,
Yeah.
why would you not just use volume automation?
Where would you do?
Reason why you use utility instead of just using master volume?
Because the master volume, you want to have that not automated so that you can continue to adjust the level.
Yeah,
Whereas,
that makes sense.
so you, or like even if you're doing, so say you want something to get louder over time,
Yeah.
just use a utility and then use the gain on that. Because then when you're mixing, if you want to turn that entire channel up, you can still use the actual mixer to change that. And also,
You don't have to select the whole thing.
yeah.
Yeah, which is what I do.
Oh yeah, that's tedious. And also you wouldn't be able to do the 3 frequency bands differently that way either. So this is sub. And then we'll start making the everything else group. And I'm gonna just grab this rack and put it onto here, but I'm gonna remove that saturation. And probably just chill out that the side chain on the mids a bit. Cool, so let's make, now that we're not working in subs anymore, we can do that same kind of technique, but we can go a lot more crazy with the harmonics that we bring in.
So can I just ask, 'cause I know we're just talking a lot on like what these oscillators are actually doing. The fact that like D is modulating C, which is modulating B, which is modulating A. But are they all separate sine waves that are adding to one another, or are they, or is it all one sine wave that's being modulated in the long run?
Yeah, so D is modulating C, which is modulating B, which is modulating A.
So it's all one sine wave.
They're all individual sine waves that are modulating each other, but if you think about that too much, it gets it doesn't make any sense. Yeah. Like that's why I said it's good to. I wanted to explain what it means, but knowing what it means doesn't help you do it at all. Cool. So this is 500 milliseconds. So let's add some attack to this. We'll add some release on there. And, you know, we can do a mixture of additive and FM by, now that we've got, so this one's modulating this one, but on the modulator, we could add some extra harmonics if we want. And let's saturate that a bunch. Maybe we'll go medium curve. Reverb. So that's going to be wub 1, wub 1, and maybe we'll just do 3 little stabs here. So instead of that kind of wubby shape, maybe we'd go for something a bit more plucky. And so all we're really working with the tone here is the level of these oscillators. And then also we're going to start messing with the coarse pitch here. So the coarse is octave and sine is like a D tune. So octaves means that it's a perfect multiple of the frequencies. So we still get nice in tune sounds. Yep.
Sorry, I can't see it. So.
Oh yeah, so that's just multiple. So if coarse is on 2, it's 1 octave above. And on something that's like so smooth like this, maybe we could add some extra raspiness by using redux. So we've made two sort of nice deeper sounds, both just using sine waves and kind of FMing them in a different way. But what we've done so far is mainly keep these oscillators, the coarse pitches, pretty close together. So what happens if we kind of start to move those coarse pitches further away from each other? And this makes a sound that I think that is where you start to go like, how does it sound like that? It's not very predictable. So we've been using very low frequencies as our carrier wave, or like the first oscillator. What about if we put this up a bit? Maybe up like that. So I can do that the same here by just adding coarse here. Okay, so we've got a high frequency. What happens if we oscillate? What happens if we modulate that with a frequency that's many octaves below? So if we've got this one on 5 and the next one on 1, we start to get this kind of like, really, you can nearly hear the ripples in it.
I went to a sound healing and there's a guy that can, the guy who was doing it, can literally like use his voice in a way that you can hear the harmonics like playing around, and he's figured out a way how to play with those harmonics just as that sounds. It's just
Yeah.
I didn't think you could make that sound.
Well, like you hear it in throat singing, and then also like if you go like, and like you can make one frequency with your larynx, but then the shape of your mouth can create like another harmonic on top of it. But yeah, that's a good reference. So if we now take this one step further, oh. So now they're 9 octaves apart. And you start to get these like really bubbly sounds that you start to hear it like more, I guess, in forest and more psytrance sounds. So I've just noticed here that this decay could be something cool to automate. So this is showing how just by using sine waves, like depending on how far the frequencies apart from each other. So starting at our sub that was the same frequency, and this sound where they're both basically the same frequency, and we've just added a couple extra harmonics here. We get that sound. And then having them 1 octave apart, 1 or 2 octaves apart, we get that. If we have them 6 octaves apart, something like that. And when they're 9 octaves apart, we start to get those bubbles. So you might ask, and I might just actually just disable this automation for a second. So that's just sine waves. The closest thing to a sine wave in terms of simple waveforms are triangles. So if we swap this to triangles instead of sines, we can see that we've now got totally different tones. So when you're playing around with these, I find it easiest to start with sine waves. And like I don't, even with sine waves, I'm still finding new combinations of these things to make new tones. But then you can start expanding, being like, okay, what happens if I use a sine carrier, so a sine as the first one, and then triangle as the second one? Oh, that sounds pretty cool. Or you could use a saw as the second one. Doesn't work so well. So if you're FMing complex waveforms together, because they're already complex, they start to sound very metallic quite quickly. So if you were going for a metallic sort of sound, maybe you would look at FMing 2 sawtooths together. But for like organic, sort of sounds, generally sticking with sine waves, you can still get so much variation in its tone. Cool. So for synth sounds like that, we can see there's a whole lot of variations there. Now let's kind of take a tangent and look at a completely different sound that we could make using FM. And this is a really kind of cool way to make percussion. And the benefit of making percussion like this is that because you're making it with a synthesizer, everything can be like really nicely tuned, and you could even have like a sort of melodic variation in there. So let's start by just adding some 16ths. We'll shorten them up a bit. And maybe we'll just add a little bit of groove. We're not going to add any swing for now, but I will just add some velocity variation. So I'm going to make those a little bit shorter and add some release. Now if I turn on this second oscillator and turn on sine wave, so we heard what it sounds like if we're kind of adding it consistently, but what if we just want to FM the very beginning of it to give it more of a plucky sound? So remember plucks, we always look at envelopes that like this. And I'll add some more pluck. And now we've got something that kind of sounds like, you could say like a bell or a mallet or a xylophone or something like that. And it actually is kind of The reason it sounds like that is because when you hit a xylophone, when that plank thing, whatever it's called, first vibrates, it vibrates in kind of a chaotic way where there's lots of higher harmonics, but very quickly it ends up resonating at the frequency that like it wants to resonate at. So that means that we see harmonics come and then the harmonics all drop off and we're left with just the frequency of that mallet. And that's what we're doing with these extra oscillators. We're saying we're going to have extra harmonics at the very beginning, but they're going to drop off. And as I said, the benefit of this is you could add like a little... You could add actually some sort of little melodic stuff to your perks and you've got total control over the pitch of it. So look, it sounds somewhat instrumental at this point, but it's still kind of like a bit synthesized. But Ableton has this really cool plugin, which I think kind of gets overlooked a lot, but I use it constantly because it makes a really cool organic sound, and that's called Corpus. And what Corpus does is it goes, imagine that we're actually just taking the frequency of your synthesizer and we're vibrating a physical object with that, and what we're hearing is what it sounds like when we vibrate that object. So to set this up, what we want to do is just click this little arrow here and go MIDI from, and we want to set this up from the same channel. So, and we'll go frequency last. So what that means is that the corpus, the membrane that we're resonating, is going to resonate at the same frequency, because otherwise it sounds like this. And we can hear it's just banging away at C, and it's not really in tune with our sound. But if we have the frequency turned on with the sidechain, now we can see that it's actually resonating at the same frequency. And you can move this little dot around in here to change the decay. And you can, let's just go all wet. And we have 7 different membranes. So we can go beam, or we can go marimba, or we can go string, or we can go membrane. See, there's some points in there that get really resonant, so you kind of just want to tune it with moving this circle around. There's plate, pipe, or tube. That's without it, with it. And of course, we could automate this radius. We could automate the decay over time. So maybe towards the end, we just want to add a little bit more decay. And then we'll put an auto pan on there, have that synced to 5/16. maybe on this sound, we could also put that auto pan, and we'll have the amount going up. And then that way it's like swapping ears and getting wider as it gets louder or more resonant. Cool. So as we can hear, we're starting to like build up a track and we still haven't even used the filter yet. So I think it would be nice to have some sort of more harmonic or some sort of chord in here or something. We're pretty much just banging away at the root note at the moment. So I'm going to put in a bar here and just chuck in our D note. And I'll make our main triad, so I'll set this as D minor, and the triad is always skipping the pink note, so we skip one pink note, go to the next, skip one pink note, go to the next. Grab our oh, they're the notes that are yeah. So we're skipping one note in the scale, skipping one note in the scale. And I'll make this an inversion by grabbing the top note, holding down shift and putting that below. And a way to make this swell in a really nice way is if we have these kind of these extra harmonics coming in at different points. So I'm going to grab a sine wave, and this first one, I might have this build all the way to the end of here, like a wub. So that's 2 seconds. Yeah. Pardon? It says just down there. And we'll add a bunch of release to this so it doesn't just stop automatically. But we also want to add release to this envelope. But now with this next one, maybe we'll have this peak halfway through. So that's at 1 second. So we'll add 1 second in here. And then we'll have this sort of doing a decay. and some release. So we can hear that the third oscillator come in and then sort of dip away, and then the second one comes up. But there's a change in tone as it does that. There's a lot of mids in here, so I'm just going to duck this on the EQ a bit. And just like the other ones, now that we've got the basic shape, we can experiment with the coarse pitch here. Maybe we'll just go 1 for that one, and this one maybe we'll do 2. Put a nice big reverb on there. Cool. How are we going? Do you want to take a 5-minute break, or are we good to keep going? We did start a little bit late, so all good?
Yeah.
Do you have any questions?
What is FM?
Fre-
I don't know why I don't know that.
frequency modulation.
Thank you.
I think I'll duplicate this, put that wet dry on 100%, consolidate, freeze and flatten. Cool. So using FM and sine waves, we've been able to create all of these sorts of sounds that you would usually think of as starting with like a sawtooth or a square wave or something and using a filter to take it away. But instead, we've built it up by using FM, and it gives you this really nice and sort of organic sound. I always think of like, you know, a sawtooth that goes up like this and then cuts off and then goes up like this and then cuts off doesn't really exist in nature. Like, you can't have a wave that just goes like that. Like, maybe a nature example of that might be like a cicada or something, which has like a membrane that's like they're using a muscle to go like this, and then it snaps back, and that's why like cicadas go and have that like kind of really like buzzy sound. But in general, a lot of the sounds that are created are like sine waves. Even like instruments are sine waves in a way. Knowing what we know now, we can have a look at some of Operator's presets and kind of have a look at how it's making a bunch of these different sounds. So let's go back to an old favorite, which is the bell sound. See, that's a pretty convincing bell sound. But if we click into here to see what's really going on, we can see we don't have a filter at all, and we just have a sine wave and some sort of square, but let's turn that into a sine. Doesn't really change it that much. Another sine. Let's cut the reverb away so that we're not getting confused by that. There's like this, there's a clicky bit that you can nearly hear the bell being hit. Well, let's start turning things off until we see that go away. I guess that's kind of it. So actually, that kind of scrapey sound that we can hear there is just a sine wave that's 26 octaves above, and it's just got an extremely fast little transient. So if we were to push this decay out, we can pronounce that a bit more. And the other one that's happening is here. So we can see this one is 48 octaves above. It's just crazy higher. And you can see that's sort of making this scratchy sound. And they've just pulled that decay right in. So I feel like that's pretty fascinating that you can make such a convincing bell sound just from sine waves at different pitches. What about... Guessing this one's pretty... Oh, that's a wavetable. Tell you what, one thing I don't like about Ableton 12 is that as soon as you start searching something, it takes away what instrument they're in, because you can't search for like an operator sound because it just shows you everything. Grand piano. So again, and again, so this sort of bass guitar sound is again just, we've got a sawtooth as the oscillator, and then we just have a couple extra sine waves that are either the same frequency or 1 octave above, and they've just tuned these levels just right and created a pretty convincing bass guitar sound. So again, if you're trying to simulate instrument sounds, or if you want something to sound sort of instrumental, a good start is going to be using sine waves and simple oscillators and just trying to tune those. And you'll this is sort of where you can get to the point where you could look at a YouTube video for how to make X instrument sound, and you could probably follow along because it's just going to be kind of what we've looked at in this lesson. So the next part that I want to talk about is going on with our kind of theme of how to add extra harmonics to a simple wave is neurosound design. So this is using, like, abusing distortion to add harmonics to what is otherwise a very simple waveform. So I'm going to grab an operator. And the first time I learned this, I was like, you can't do that. Because I came from learning psytrance sounds that are all about keeping it super clean and just, just saturating it just the right amount. So we'll start with our nice low, clean sine wave. And what we'll start off with is we want to add something that is going to clip it. So when we clip it, actually I'll show you what happens when we clip it. I'm going to use this free plugin called Oscilloscope. And this is just going to show us our waveform. So we can see here now, we've got a beautiful clean sine wave. And the dirtiest way to clip something is just going to be with a limiter. So I'm going to put this limiter in here. And as I turn up the volume, we can see that we're getting this gain reduction here. And our sine wave is starting to flatten out a bit. But if I duplicate this a bunch of times, you see the more I do this, the more we're flattening the crests of our wave. And we're basically slowly cutting off the sine wave so much that we're turning it into a square wave. Now, limiter is a very digital way of doing this. So what we get is kind of just like a sort of digital square wave. When it comes to compression and clipping and stuff, I just think nothing does it better than Ableton's glue compressor. In fact, for quite a while, I was using a VST called the Cytomic glue compressor, which I saw on like a Futurephonic masterclass, and someone who was using Cubase was like, this is the best compressor you can use. And so I bought this Cytomic glue compressor and I was using it a bunch. And then one day someone was at my house and I was using it. I'm like, man, you got to get on this glue compressor. It's amazing. And they're like, oh, doesn't Ableton already have that? I'm like, oh, but Ableton has a different glue compressor. And they were like, look at the glue compressor. And you can see Ableton's glue compressor is in fact made by Cytomic. And the VST I was using was just a clone of the Ableton glue compressor that they made as a VST for other people to use. So this is the glue compressor that, like, it's modeled after a really nice like analog glue compressor. So let's do that same thing, but if we want it to clip, we just have to turn this clipping on. Whoa. So we know it's clipping when that yellow light's turning on like that. So we've got a bit of clipping here, but if we duplicate that a bunch and start to smash them, we can see that we're getting all these extra harmonics as we're clipping off that waveform. And now actually, these makeup knobs kind of become tone control. And we can compress it a bit too. I'm going to add this EQ on the end there. So what happens if we make tiny changes to the synthesizer when it's going through this much smashing compression? So let's do what we did before by just adding another sine wave. we can start to get some seriously gnarly sounds. And what was before making it, like, maybe I'll group all these so I can do a A-B. So what this sounds like without all those compressors is that a relatively subtle change, but with all those on, we're getting all of these sorts of different tones. So the kind of formula with creating neuro sounds is we start with something really simple. We add a lot of harmonics through clipping or distortion, and then we want to start shaving some of those frequencies away. And that's where we will introduce our first filter of the lesson. But we're not going to use a low pass or high pass or a band pass or any of the other filters we've looked at so far. We're actually going to use a notch filter. So all we're doing is just removing a small notch. So I'll turn off all this stuff we've made so far. So we're taking some frequencies away. So now we want to add those frequencies back. I think maybe with an overdrive. A handy thing about overdrive is that the frequency range here is actually the same as the frequency range of the filter. So I believe, or at least it's close enough to make this work. So I'm going to turn on this automation, just pop that one down so I can still see it. And I'm going to pull up the automation of this frequency. And I'll select all that. And just copy that into my distortion. So we can see we're taking a notch away, but then we're distorting those frequencies that are missing. So we're kind of filling in that gap again. And just close all those glue compressors for now. And then we're going to use the multiband dynamics that we saw earlier, but we're actually going to use it as a compressor. But we're not going to go too deep into how to set it. We're just going to grab this one called OTT, which stands for over the top. So what this does is it squashes all the frequencies, so they're all basically the same volume. And we can see that in our frequencies here. So if I have this turned off, we have a lot more mids and a lot less highs. When I turn this on, it just flattens it out. And then we just want to look over here to these outputs, and we can use this as like basic tone control. So I can give it some more mids. And now that we've got a whole lot, now we've got all our frequencies back again, maybe we'll do another round of auto filter. And we looked at the notch filter. What about we look at, well, what's this last one? That kind of just looks like a low pass, but we have this morph knob here now. So we can see this morph knob actually moves this around like so. So let's draw a bit of automation in for that. Don't know. Ooh, doesn't sound good down there. And then maybe we'd add, well, okay, so we've just done some notching. So after notching, we always want to add some sort of distortion. So you could add, you know, maybe you'd want to copy, you could copy your crazy glue compressor chain again. You could use overdrive. I reckon this time I'm going to use saturator. I'm just going to put -10 on there to begin. Some sort of distortion. So it could be overdrive, it could be saturator, it could be Ableton's new raw distortion. It could even be the clipping like we did with the glue compressor. There's not really any, I would say the main rule here is just notch and then distort, notch and then distort. But how you distort it is up to you. Basically, it's just going to add different tones. Now, a sound that I commonly hear in these sorts of like neuro sounds, which are kind of like traditionally more of drum and bass sorts of sounds, is this like bit of white noise on the top that's just consistently there. And how we add that is with a tool called erosion. So here's the erosion here. And what erosion does, if we put this on noise, we can hear it adds that sort of hiss to it. And the effect that I've kind of felt when there's erosion on a bass sound is it sounds kind of like the speaker is ripping or something. Like, I don't know if you've heard those like drum and bass tracks where it literally sounds like the bass rips are like the speakers are breaking, but somehow it's clean at the same time. That's where using erosion is really powerful, because you're basically adding a small band of white noise. And you could either move that around or keep it static. All right, so you're probably wondering, how are we going to use this in the context of this track? Like, it just sounds like we've just made this crazy, hectic, distorted bass sound, and you know, maybe you could use it as a really gnarly stab or something like that. But how do we actually use this sound? Well, now we've created a super harmonic waveform that has all of this interesting sort of filter movement inside of it with the notch filters. And we could also automate this, or we could really automate sort of whatever we want. So I'm just going to go ahead and automate some more stuff. More movement's good. I'm going to delete that so keep this consistently the same level. So usually what I'll do here is I'll make this big chain, and they always turn out differently. Like when you're doing so much chaotic automation, don't expect to necessarily know what the end result's going to be like. But again, that's sort of part of the exciting part about using neurosound design, is that you're just fucking up the waveform basically. And then at the end of that whole thing, we'll add an auto filter. And that's like where the main movement's going to come from. But it's going to be a lot more interesting than using a static wave and just making a wub, because inside that chain that we made, there's all of this stuff moving around. So every time we get a little snippet of it, it's going to have so much movement. So I'm going to grab an LFO. And add an audio track. Record from 14. Hit arm. That's going to go on there. And you might ask, why don't I just use this LFO? And that's because this LFO here has the ability to change the shape, where we can make it more like that or more like this. And this LFO doesn't have that ability. So this is going to give us a little bit more control. So maybe I'll put this on. And I'll go ahead and just record some of this. Oh, but we don't want to record the automation on this one. So I'm going to turn that off. Let's go. So ideally what you'd do is you'd have a MIDI controller and you'd have this frequency mapped and the rate here, the shape here, the depth and the offset and then the waveform or something like that. And then you're actually just jamming that and you're creating all these different unique movements of the sound. And this is actually what I'll end up using in the track. So all of these sorts of like rips and wubs and stuff, especially the ones that kind of go do 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 do, but like they're a little bit out of time or something like that, usually comes from automating this LFO and just getting a whole bunch of takes and then chopping out the ones I like and arranging them. So if I turn off automation mode and I go show take lanes, maybe we'll grab a couple stabs.
Okay, when you're recording and the waveform is small like that,
Yeah.
does that concern you in any way that it's so small?
Yeah, not necessarily. Like,
I know you can push it up and down.
oh well, that's just zooming. That's not actually. That's not changing the volume of it.
You can use your volume, which is usually what I end up doing in a lot of cases.
Yeah.
But
Maybe I'd probably, if I wasn't doing it in this environment, I probably would have this channel just a lot louder, as long as it's not clipping into the next channel. Like, it is nicer to work with like fatter waveforms.
So you try to have it so it sort of fills the clip a bit better.
Mm-hmm.
Yeah. But it's not a big deal, is it?
Nah, it's not a big deal. I think like, especially in like such a high fidelity digital space, like you can always just gain it up, and it's not like we're adding distortion by gaining it. And especially on a sound like this, it's like, what's another bit of distortion? It's fine. Especially like these sorts of deep sort of knocky sounds, I really find like I use these sorts of sounds quite a lot, and we can see that they're not actually synced, which could be a good thing or could be a bad thing, but a lot of the time it's a good thing. So how we select what we want to use is if we grab some of that, we can press enter or space, enter, and it just copies it up the top there. So maybe we'll grab like this sort of wub here. And put that.
So when you deleted that top clip, that's actually that second lane.
That will be this one, the bottom one. It's the last bit we took. Maybe I'll grab something like that. That is Control Alt and Shift. So even though I just chopped out a little bit, if I double click on this, we can see that this is just one bit of that entire recording. And if I hold down Control and Shift, I can move around which bit I'm selecting. So that's another benefit of recording one really long audio clip, because realistically, I can close these take lanes, and wherever I want to sound, like maybe there could be a pluck, I'll just grab that you know, but I don't want that exact take of the pluck. So I can just hold down Control Shift Alt and try a different one. That one's all right. Maybe this one. It's a bit deep. And here we can get a different one. And I guess there we probably want some other sound, so I'll just put a bit of the clip there, doesn't matter which bit, and I can just scroll through here. That's a little bit too early. I feel like maybe there we'd want some of those wubs that we did at the end. And I know that those wubs are like way deeper in this clip, so I'm gonna just go somewhere over where they were. Just press Control L and I can jump to that bit. Oh, that bit there, that little glitchy bit could be cool at the end. Reverse that little chunk there. And I'm thinking this bit where there's this like bit of space here, maybe instead of adding a bass note, we just want to have a reverb tail. But if we add reverb to this channel, then as soon as these ones start, we're going to have to chop that off. So this is going to be a great time to use that send. Which means that when we automate this little part, it means that we're sending that audio to A, the reverb. So let's jump in there, make that a bit longer, and we don't want any lows in that. And maybe we'll send that one as well. That one too. Now, like, could you imagine if we actually tried to draw in all of this automation on that long wave? Like, it would just be, you might be able to do it, but it would take so much longer. Like, we just, like, you know, it took a bit to set up the chain, but then we recorded for like 2 minutes, and usually I I would try and get it in a bit more of a sweet spot, or I'd record for longer, and then once it's in a sweet spot, stop recording and then record like a couple minutes of it in the sweet spot. And then you just have this clip with like so many cool different sounds in it, and all you need to do is just grab a bit of it, move it to where you want another sound, and you can just scrub through to find the sound that works. And then all you're really doing is you're focusing on sort of the groove you want to make, rather than trying to tediously do the automation for each one of these hits.
Good news, you can make 3 different versions of the operators. So you have 3 different tones. So, and then you make a section
Yeah.
out of 3 different, or even 4, or whatever you want.
Well, you could nearly apply the same concept, to all of these sounds and just record a bunch of it.
On top of that, if you wanted to.
For sure. And like, as we heard in here, like, we didn't even really play around with the synth at all, where the thing about creating this crazy long chain is now every little thing we change in here. Is this thing on? Yeah, possibilities are endless with that. So let's see if there's some way of making sense of everything. If maybe we can fit all this stuff together. So I'm going to call this the beginning of a melodic group. And we'll put that in there. The other thing that I find that's really nice about kind of the sounds we've made in this lesson is that we have some really nice, smooth, organic sounds, which are sine waves. And then we've got these heavily distorted sine wave sounds. And that's going to add really nice contrast as well. So maybe the tune would start out with just the kick and bass. And what happened to this MIDI? Got lost along the way. Cool. Any questions? Anything that was a bit confusing? I'm guessing that this sort of neuro rack is a bit overwhelming because there's a lot of stuff, but I think if you follow along, you'll find that it's kind of just a lot of distortion on something that's really just a simple waveform to begin with. And as I said, the kind of main thing is that you want to start off by heavily clipping the sine wave with, I like to use glue compressor. I think it sounds the best for clipping. And then we just go in stages of notch filter, some sort of distortion, OTT. When you put the OTT on, use these three knobs to get the tone back that you want, because sometimes it takes too much of the mids out or too much of the highs out. So we just use these three, high, mid, low, just like an equalizer. And then we'll do more notch filtering, more distortion, more OTT, and you can do that as many times as you want to make a really just kind of like wishy-washy sound. And then at the end of that, we just put a low pass filter on it and record out a bunch of hits, which ended up turning into which you'll hear a lot in my tunes, probably listening back to it, especially the Sciotech stuff. I've been doing this heaps for these sorts of like bass plucks and stuff. I just find, like, even if you look at these sounds, like, oh yeah, well, that's one thing that we didn't do, and I kind of just for completeness want to add this. We started with a mono wave, but if we increase the spread here, then you can get a lot more stereo in that sound. If we open up Digicheck, we can see it's heaps wide there. But even with having the spread all the way to 0, yeah, see, that's pretty mono.
Is that your baby face?
Yeah. So yeah, when you're going through this neuro process, just remember to add some spread here to get some more width, because that's really going to make these sounds sound just absolutely huge. Cool. Yeah, if we don't have any questions, I think I'll end it there. Certainly pretty advanced sound design, or at least, let's say, complex, because of how complex the waveforms get. But the main takeaways is, instead of using filters, we can use sine waves, and all we need to do is change the level of the sine waves here and the coarse pitch. And if we want to add movement, we can adjust the envelopes, but we're not really touching this side at all, except this spread here, if you want to make it wider, which I recommend you do to some degree. But yeah, just by playing around with those few things, you can get so much variation. And that's the beauty of FM, is that you have one simple waveform, but you combine it with another, and suddenly you get something more complicated. And if you go up to using 3, then it gets more complicated again. And yeah, it's a whole world of new tones to explore. So yeah.
When you choose an operator,
Yeah.
and you choose the way it feeds into itself, does it come up as that's the first preset, and then you can choose any of those after that if you wish to?
Yeah, by default it's this one.
Yeah.
And I'll be completely honest, I don't think I haven't even started to explore these ones yet. Like all of the sounds I've made have been pretty much just this one. And I mean like, I don't mean like I haven't started to explore them in this lesson. I mean like in my production, I've like hardly ever even branched out into those ones yet. I'm still just on level 1 and yeah, still having so much fun with it. Yeah.
And this is just how the oscillators are modulated.
Yeah, so the easiest way to see that is this one, they're all connected, and this one, none of them are connected. So that's just 2 sine waves. That's them FMing. This one means that D and C add together. So they add, not FM, but then them added together, FM's the second one, FM's the first one. This one is like the D and C are FM together and then added to B and then go into A. But I don't know. I feel like trial and error, because also at this point you can do your sound design and then you can just click through these and see. Well, I'm only using 2 oscillators, but if I had more of them engaged, I suppose you can just kind of click through these ones. And maybe one of them you'll just click on and you'll be like, oh, that actually gives me the sound I want. But when I look at that, I think, I don't know how to like design with those. Like I'm not at that level of complicated FM where I could even really start to think about that. Maybe this one could be cool because then you have like a two-wave FMs that then get added together at the end. But yeah, I would just kind of just play with the first one really, and yeah, then click on the other ones if you want, but I haven't even really attempted to try and consciously use those because I'm still just on the first one. Cool. Well, thanks again for everyone that came. Really appreciate it. And yeah, I hope you enjoyed this lesson. So next week, we're going to look at arrangement and structure, and that will probably incorporate a bit of mixing as well, mainly sort of like level mixing and like getting the levels of individual tracks right. And then in the last one, we'll look at like mix downs and like marketing, mastering and that sort of stuff. But yeah, the mastering component will be just an overview of like what mastering is and how you could master a track to like play in a club or something like that. But not like professional mastering. I don't really know how to do much of a professional master, and I think teaching it in a space like this, probably the details would be lost. Because it's like, can you hear that difference in that tiny compressor setting? It's like train goes past. Awesome. Cool. Thanks a lot, guys.